Hello everyone, this is our first video on momentum from our momentum and impulse section. So this is the idea of momentum. Momentum is a property that's related to an object's mass and also related to an object's velocity. So previously we were talking about force, which is mass and acceleration. Now we're going to talk about the effects of mass and velocity. So for example, when we are going tobogganing, if you got the toboggan set up just right and you're a little bit more massive, so for example, me versus my son on a toboggan, I definitely have a much harder time stopping than my son does, who is, a quarter my size or smaller, and probably a third my size. And then he's, who will actually have trouble getting down the hill maybe because he can be so light. So this is all a factor of momentum. So in physics, momentum is referred to as the amount of motion in an object. The greater the momentum of an object, the more difficult it will be to alter the object's motion. To bring any moving object to a stop, its momentum must be reduced to zero. What determines an object's momentum? Well, an object's momentum is determined by its speed or velocity and mass. And in fact, let's just put a multiplier in there because that's what the factor is. So it's velocity times mass. So to put another way, what qualities of an object determine how it moves and how difficult it can be to start, stop, and accelerate. So the factors that determine momentum are velocity. Fast-moving objects are difficult to stop. This is one of the factors that makes makes a baseball that's flying towards your head more dangerous than, say, a tennis ball. A hard ball versus a tennis ball. If a hard ball is that's traveling faster than a tennis ball, then one will have more mass than the other, more velocity than the other. The faster you drive a car, the longer and harder you must brake before you come to a stop. If we also think about a car versus a bike, a car and a bike, they probably have different velocities, so they have different momentum. Getting hit by a fast-moving car versus getting hit by a less fast-moving bicycle or even a similar-sized object is a different amount of momentum. So since momentum is about motion, it can be calculated with the following equation: mass and times velocity. So the other factor here is mass, which I did not discuss in this earlier, but that's okay. So the other factor that controls momentum is mass. Possibly, let's put a little note here that they say first and then they don't continue talking about second. So let's put second, mass. More massive objects have more momentum. So when we're comparing two, we can compare a couple of different situations and talk about the amount of momentum. And a momentum is a quantity that can actually be a vector quantity because velocity is a vector, so that transfers the property of direction to momentum. So momentum also has a direction. So we can even look at an object like, a bus or a truck like this, and we can say that the truck if it has a velocity forward, then it also has a momentum that's going forward, which will be equal to its velocity, which is going forward. So these are vector properties. They have a direction. We can add those directions together. We can treat them as interrupting and adding and addable and affecting each other. Summable, I guess. So momentum is represented by the symbol P and is measured in kilogram meters per second. And I really wish there was a nicer unit than that, but unfortunately that is the unit that we often use. So kilogram meters seconds, you can write it that way. In your physics class that you might take in grade 11 or 12, you might see them put in -1. This represents the division by S. So that's another option for organizing it. Or they might simply just write, especially when you're writing it by hand, you can put the seconds on the bottom like so. A dot is often used when we're talking about units because we don't want to put an X in there because an X could get confused as a letter. So here's some ways that that momentum can be calculated and use. So for example, a body moves at 30 meters per second and it has a mass of 40 kilograms. Let's calculate the momentum. So in this case, we have a speed. So I'm not going to put an arrow. We don't know which direction it's going, but it's moving at 30 meters per second. And we have a mass, which is 40 kilograms. So then what is the momentum? Well, the momentum is mass times velocity. So I'm going to do the 40 kilograms, and I'm going to multiply that. I like to do brackets when I multiply, but you're free to do an X or to do a dot if you like. And that result is that P, our momentum, is going to be 100 and I think it's 1200 seconds. 1200 kilogram meters per second. Do I want to pull out a calculator and double check that? Just double checking my zeros there. 40 times 30, yeah, okay. All right, and so in example 2, we have a object that is, we have the momentum of an object, so we have P, and that is equal to 12 kilogram meters per second, and its mass is equal to 3 kilograms. What is its velocity? So velocity, we need to rearrange this equation. The only equation we have, so P equals m times v, and so we can rearrange this by moving the m over the equal sign, and that will leave us with this equation. And later on, we're going to need this version where we're going to leave the mass behind and divide away the velocity. So those are the 3 different versions. So let's replace this with that new equation, momentum divided by mass. So that would be 12 divided by 3 kilogram meters per second, kilograms. Those kilograms cancel. And so then the answer is that the speed is equal to 4 meters per second. This is speed again because we don't know what direction it's moving. What is the mass of an object moving at 4 meters per second? So that's my velocity, 4 meters per second, and which has a momentum of 2 kilogram meters per second. Okay, so then we're going to say that the mass is equal to momentum divided by speed. So mass is equal to 2 kilogram meters per second divided by 4 meters per second. Meters per second cancel, and that leaves us with a mass equal of 0.5 kilograms. All right, so there are some questions here to discuss. So so you can pause here if you like and try these questions, and then we'll come back and do them together. So I'm just going to pause for a second. Okay, and we're back. So for each of the objects listed below, indicate the amount of momentum. To enter your answers, use the following: high, low, moderate, or none. So this is we're just going sort of as an idea of sort of an intuitive scale, not an accurate scale. So a transit bus moving in the designated lane. So that sounds to me like a large object, right? So a transit bus, it's a large M, and it's moving in designated lane. So I guess it's just traveling in its normal lane, but it is traveling, so it probably has an okay velocity. Moderate velocity. Moderate. So this is probably still a high amount of momentum. A large object like a bus probably going to hit you, and you're not going to want to get hit by that. Okay, if a football pass, so this is this is someone passing you a football. I'm assuming it's an American style football, not the football everybody else in the rest of the world uses, that we call a soccer ball here. So this football is getting passed. You know, you can get hit in the head with a football, and you don't really have that doesn't hurt too much. So I'm going to call that one a low. Now a sprinter running a race, here we have a low mass, relatively speaking, but we have a high velocity. But, you know, a high or medium high velocity. So let's go that moderate. You know, if I had to choose between getting hit by a bus or getting hit by a sprinter who's doing a race, I'm still probably going to pick the sprinter. So I'm going to call that a moderate. Now a statue, this is an interesting one. If a statue is just sitting there, then the velocity is going to be 0. So if the velocity is 0, then this means that therefore the momentum is going to be 0, because momentum is velocity times mass. So this is going to be an N for none. Okay, race car driving in a race. Here we have a very fast car, right? You know, a fairly large M, not as big as a bus, but still driving very, very fast. So we've got a high mass, we've got a high velocity. So that's definitely going to be a high momentum. Marathon runner in a race. Now they're running a little bit slower, right? Marathon runners are, well, you know, they're still running pretty quick if it's an actual real marathon. So I think we're going to go with the same deal as the sprinter. Maybe if we're thinking about the sprinter being a medium, let's give this one a low, just because it should be less than a sprinter. They're probably not running as fast. Let's go assuming they are running slower than sprinter. Okay, a slap shot headed towards the net. Again, we have a light object, right? So this is a puck is a low mass object, but it's very fast. Very fast. So, you know, this was probably still a moderate amount of momentum. And in fact, you know, if you think about getting hit in the head with a football versus getting in the head with a slap shot, probably a slap shot, you know, they wear helmets for a reason. Now a building, not moving, so that means that we have none. And then a skateboarder heading downhill, this is probably on par with the sprinter, so they have to be at least a medium probably. They're on wheels, they're going quick. And that's sort of the idea. So that's just a general sort of sense. Can you get a sense for momentum? Okay, here's a table, and I will show you how to fill out the next the first couple of lines, and then I'll fill out the rest, and you can check the answers online. And so here we go. So a transit bus has a velocity of 50 kilometers per hour, and it has a momentum of 400,000. So for mass is equal to momentum divided by velocity. Velocity is equal to momentum divided by mass. And momentum is equal to mass times velocity. So I should take the 400,000 and divide it by 50. So I'm going to get my calculator out again. So 400,000 divided by 50, and I get 8,000 kilograms. That's about right, 8 tons. To do the velocity of the football, I have a mass of 0.5, and I have a momentum of 5. So I'm going to take my momentum, divide it by my mass, and I'm going to get a velocity of 10. I'm going to do the next two, and then you can practice on your own. So a sprinter here, he is going at a velocity of 25, and he has a momentum of 1875. So I'm going to divide that momentum by his velocity, or her velocity, and that's a 75. The next one is the Golden Boy statue, and notice that the momentum is 0, even though it has a mass, and that mass is 1650. But if we take 0 and we divide it by 1650, we still get 0. So that has to be, the statue's not moving very much, is it? We have one more here. We have 4,633 463,500. This is the momentum of a NASCAR stock car racer. And so we divide that mass away, and we are left with 300. Okay, I'll leave the last 4 for you to look up on the classroom website. And with that said, we will be back with impulse probably next week, or on our next lesson at least. Have a great day.